So today we're going to learn all about chamfering and angles, and while we do that, we're also going to include in a little bit of circular interpolation in the corner. So if you're looking at the screen, you should be seeing this turning number 4 video tutorial part. I've got HSM Edit open. You could also be using Write. It'd be the exact same thing. Just a way to get our format into our format of our program into the machine. So just kind of doing an overview of our part. I've got 3 diameters listed out here: a 5-inch diameter, a 3-inch diameter, and then a 2-inch 20 thousandths diameter. That's the small side. I've included some information enough for you to get this angle on here for everything that you need for it. Really, everything is given for it already. You've got a length here. I've not included the radius size in there. We're going to call it 100 thousandths for the radius. You then come up this face. You've got a chamfer. I've only told you it's a 45-degree angle, and I've told you the hypotenuse. And so we're going to figure out both of these 2 legs today. You've got a 1-inch length here, you've got 1.83 here, you've got 4 inches here. So we can do the math as we go. So we're going to go ahead and take a look at our part, just kind of getting an idea of it before we go too far. And so I've already got one that is pretty well marked up for us. So we can take a look at that one, and it'll help us to know what it is that we're working with today. So same print, I've just marked up some stuff on there so that you can kind of see that just a little bit better. So when we're traveling through our part, we're going to know that we're starting at, right, you're going to start right down here as you make this part. So typically we would chuck up this material. It's going to be 5 inches or a little bit bigger. It's going to be sticking out of the chuck at least 4 inches. If we part it off, then we need to be letting it stick out a little bit further. 5 inches is going to be pretty solid to part off. That's a pretty decent sized part. So we may just turn back just a little bit further, and then maybe it goes to a sawing operation or a secondary operation that gets off the bulk of the material, or maybe it's just a chucked part, and maybe we just don't go quite back as far. Flip it around, hold on this diameter, locate on this face. Do a facing operation to bring it to length, and then maybe turn the rest of this diameter. A couple different options that we can do on that. So we can work that one out as we go. When we're traveling up this part, let's just kind of walk up across the diameters and dimensions on it, and we'll do the math as we go. As you can see, I've already got some of that stuff on there for you. So I've got 75 degrees here, that's coming off of this face, so you'll be traveling up 15 degrees. So you'll start down here, and at this point we have 2.20 or 2.02, and that would be Z0 at this point. Then we would move up this angle, and then that's going to bring us to 3-inch diameter back 1.83 for our diameter, or our length there. From there on out, we need to travel back to the beginning of this radius. So we won't travel back 2.83, we'll travel back 2.73. At that point, we'll go ahead and that's this down here. We'll go into our G2, traveling clockwise. We have to enter in from this point here. We've stopped right before this angle, or before this radius starts, and from there we're going to have to enter in our destination point. And so that would be how far back we're going to go, and then where we're going to end up at in X. And then we need to include an I, and that I is going to be your incremental movement in X. Okay, so it actually kind of forms a capital I as you move up through here. So I is incremental X, K is incremental Z. We're not traveling anything in incremental Z because as you notice, this center point of these circles only goes, or these start points of these 2 points are only going up in X. So the start point of it would be at 3 inches minus 2.73. The final destination for it would be 3 inches, or 3.2 Z minus 2.83. So That would be our G2 move, and we'll walk through that a little more clearly as we write the program. So from there on up, we travel up this face, but at this point we don't know how far to travel because I've not included some of that information. So what you need to know, or what you do know, is you've got an angle of 45 degrees. You have a hypotenuse of 354. So one way that you can use to figure that out is you can take the sine of 45 degrees times the hypotenuse of 0.354, and then that'll tell you that what your distance is in X and Z across here. And so that dimension is going to be 1/4 of an inch. So you come up through there, so you start here, and then you'll travel up at an angle, traveling in X and Z. And then from there on out, we might go back just a little bit here, and then we might stop it in case we decide that we want to finish this on the second side, just as a turnaround part. Okay, so let's get our program started, and we'll walk through some of the other details as we go. All right, I've already got a print sitting in front of me, and we'll just start walking through this thing. All right, so as always, I'm going to start with the % sign, and that's going to tell my program when to start, when to kind of open up its mouth and start taking some program in. From there on out, I've got my caps lock already turned on, so I'm going to go 00004. That's going to be my program number. I'm going to put in parentheses my name, first name, last initial, or first initial, last name. And then let's see, put that in parentheses. The machine will not do any kind of action from that. It'll read it, but it's not going to do any action from it. Okay, so from there, in our immersive simulator, tool 2, so T202 is our turning tool. Now, as you're running on a machine, that may not be the same for every machine, but tool 1 is a part-off tool, and then tool 2 is the turning tool for us. So next, I'm going to go ahead and put my work offset G54 for us. For this project, it's not really going to make much difference what we do with that. It's a modal command, so it would always default to G54. We want to make sure that we're always putting in G54. We want to have some redundancies built in, so the same thing I would do at G0. And then I would do a G20, a G40, a G80, and a G90. And so what that's going to be is that's rapid command, that's inch input, that's cancel cutter compensation, it's cancel can cycle, and it's going to be an absolute movement. So those are all be just commands that I put in there for redundancy. Normally my machine would already have those as defaults because all those are modal. So next thing that I want to do is go ahead and set my spindle max G50, and I'm going to stop this at so S, let's say 1200. So my spindle will not spin faster than 1200 RPM. So next I'll go into a G96. I do want my spindle to have a constant surface footage so that my spindle speeds up and down as it goes. So as I go closer to the center, my spindle's gonna spin faster. As I move out towards the limit switches on the x-axis to the high side, everything would go smaller, or everything would go slower. So G96S, let's go 600. Also turn the spindle on at that point. So M3 is gonna turn it on. M5 will turn it off. A lot of other commands will turn it off as well. So you may have a machine that has the ability to do some additional commands with one code. So like an M13 might turn the spindle on, and it might also turn the coolant on. So for us, we don't have that, so we're just going to turn our spindle on. And so from there on out, actually I probably would have went ahead and put, I'm going to back up just a little bit. As I go up here, I'm going to go ahead and put in a G28. So back up, put a G28 in there. That's a home position. So I'm going to go home for X and Z before I even get started, just to make sure I'm out of the way and ready to go. You may not do that on your machine as you're working in a shop, but for us, for our situation today, that's going to be a really good one to do. Get yourself out of the way before you get started. That way you don't have an accidental tool change too close to the workpiece, or even the door or something else. Okay, so from here on out, I'm ready to basically start taking some cuts. So I've got my spindle on. I need to go ahead and move over to a good start position. That's going to be a G0, and I'm going to go to Z.1, and I'm in rapid, so I don't need a feed rate. I will go ahead and put an X on there too, though. X 5.1 and then a Z.1. So that's going to move me over to about this position, so I can get ready to start facing this material off. I'm going to go ahead and go to Z0, still in a rapid command. Now I'll switch to G1, and I will go to X minus 30 thousandths. Put a feed rate here of, let's go 15. I didn't tell you what kind of material that we were working with. I don't know that it matters on this. We're just talking about a tutorial as we go through. So let's just call it 6061 aluminum. Seems to kind of be the go-to for a lot of these. So we can spin a decent RPM, and we should be able to feed pretty fast through there. So at this point, I've fed down to X0 or X negative 30, feeding at 15, and from here on out, I'll go X or G0, X 5.1, Z.1. So a little bit of a diagonal move, just get me back to a start position. So all I've done so far is I've got my part spinning. I've moved my turret close to the part. I faced it off. I retracted back to a safe area, and now I'm ready to go into a G71, P1, Q2, U 10 thousandths, W 5, depth of cut 100, and a feed rate of, let's just keep with the 15. Okay, if you're not tracking with some of that G71, you need to go back and look at some of the other videos that we covered some of that stuff with. So we covered some can cycles and some roughing cycles in some of the previous videos. So go back and take a look at those. Some of them are two parts, so you need to watch the first and second part. Okay, so I've got an N1. It's going to be a rapid move down to my lowest diameter. That's going to be G0X 2.2. So from here, I'm not gonna keep tracking those numbers of N3. See how it started to automatically put some line numbers in there. I'm only going to use N1 and N2 in here, and I've already denoted that by P1 and Q2. So I'm just going to force those out of there for the rest of the time. So rapid move down to my lowest diameter. That's 2.02, not 2.2. So that'll be down to this diameter right here. So my next motion will be a G1, and then it's going to be to a Z0. That gets me to the front of my part. And I'm just going to let those numbers roll, and then I'm just going to pop them back out as I go. So I've fed up to the front of my part. My next move will be a diagonal move. That's going to be taking care of this motion up here, okay? So I don't really even need to know the angle of this because my print already shows me how far back I'm going in Z and then where I need to finish at in a diameter. So I need to go to 3 and I need to go to 1.83. So I can go X 3.0 and Z minus 1.83. Type the right numbers. So next, I've got to travel back here to start this radius in here. And so this is what I was talking about before with our G2. So we're going G2. That's going to be a clockwise radial move. So I'm going to turn this corner and create a radius. Now, I'm not factoring in the tool nose of my turning tool. It's probably a 30 thousandths. So I could make this a little bit smaller. So say I'm doing 100 thousandths radius. I've already got a 30 thousandths tool nose radius in my part, or in my tool insert. So I could go ahead and take that out. Just for this purpose, we're gonna just omit that part of it. We're just gonna do 100 thousandths radius on this. So I'll show you what it looks like, and then we'll go back and kind of unravel it or unwrap it as we go. So G2, X 3.2, and we'll go to so this G2 is always your destination point. So where we started at was, oh, hold on, I missed a motion here. I need to go back just a little bit further. I need to get back to that start point of that radius. So here I was at 1.83 and 3 inches. I need to go back, not to 2.83, but I need to go back to Z minus 2.73. So that's going to be 100 thousandths short. That'll be the start point of my radius. So I'm still at 3 inches. I'm at Z minus 2.73. My next move will be my G2 move. Where I want to start at, or where I want to end at, I want to end 200 thousandths, so 100 thousandths on each side, in diameter larger. So G2, X 3.2, Z is going to be minus 2.83. I is going to be 100 thousandths. K will be 0. Okay, so G2, like we talked about, that's that clockwise motion. Then X of 3.2, and where I get that from is I take my 3-inch start point. I'm going to do 100 thousandths radius, so that means 100 thousandths here, 100 thousandths up here, and so that brings me to a new diameter for my end point being 3.2. So I moved 100 thousandths incrementally for that, but I moved on the diameter, I moved 200 thousandths. So here, this X is my diameter. So my diameter gained 200 thousandths. So now it's 3.2. My Z went back the 100 thousandths for its finishing, for where it finishes up at. But I moved in an incremental X of 100 thousandths. That's my I. And so, but my K never moved. Okay, so even though my tool physically moved, my center point of that, or my swing point of that, never moved. So it just moved up in X, not in Z. Okay? So now, that's not the only way that you can do that move. Let me do another one. So I'm gonna just type this out and then I'll delete it. So G2, X of 3.2, Z minus 2.83, and then R.1. Would be another way to do that. So there's more than one way to do it. I's and K's will almost always take care of what it is that you need, but a lot of machines are going to allow you to do that R as you go. Our Haas machines will. It's probably my go-to on this. I'm typically not using I's and K's for 90-degree radiuses like this. Okay, so here's a pretty important point. As you leave this corner, as you leave this radius, you're going to need to go back to a G1, because G1, G2, all those are modal, and they stay that way until they're changed. Okay, so now I need to travel up in X. So I'm at this face, but I don't know where to go yet. So what I do is I find my diameter at 5 inches up here. And then as we talked about our math for our angle on our chamfer, 45 degrees. The hypotenuse is 354, so 0.354. So we can take, if you've got a calculator handy, and you should, you can take the sine of 45 times the hypotenuse, and it should come out to 0.25. Now, if you've got Machine Calc Pro, that's what I've got here. I'm going to pull it up, take a look at it real quick. And I've got a hypotenuse of 0.354 is my hypotenuse, and 45 degrees for my angle. So I can go to my opposite and my adjacent. It are both 250 thousandths for that. So however you do that, whatever kind of calculator that you have for that will work just fine. So I know that this leg, both these legs are 0.25 now. So Now we're done working in incremental. Incremental only happened inside of that G2, and it doesn't switch out of G90. It doesn't go into a G91 code wise. It just does it with inside that can. So what we're going to have to do here is we've got a 1/4 inch here and a 1/4 inch here for our diameter. So we have to go up to X of 4.5. Instead of going up to 4.75 or up to 5, we've got to go to up to in X 4.5 on the diameter. Our next move is going to be a diagonal move. So it's just like it's very similar to this angle cut here of our 15 degrees. So we're just going to travel in X and Z. We're already in G1, so we can just put X 5 Z. That's going to be 2.83 plus 0.25. So I've already got 0.25 plus, so 0.25 plus 2.83 equals 3 inches 80 thousandths. Okay, that now tells me, too many Z's in there, tells me where I end up at. Okay, so I think here, just for demonstration purposes or tutorial purposes, we'll go ahead and travel back our 4 inches. So we'll go, this will be our N2, and we can go ahead and finish that guy out at Z minus 4.0. Okay, so that's my roughing move from this point on, okay? So this here in my roughing cycle, I've got a D of 0.1. That means I'm going to be making diameter steps of 100 thousandths. So every time I'm going down 100 thousandths, making this cut of 100 thousandths per pass. So now, after I do that, it's gonna rough that down, and then it's gonna do a pre-finished pass, not taking any more material off of it. I've already said I need to leave 10 thousandths in X and 5 thousandths in Z. So I'll go ahead and go into a G70, P1, Q2. I have not already put in a feed rate, so we'll go 6 for the feed rate. If I wanted to change RPMs, I could do that above that if I wanted to. I'm just gonna leave it the same. This line will take care of my complete finish pass. After that, I'll go into a G0, Z, and I'll go back out of it by maybe 1 inch, just 1 inch in front of my part. I can take a look at it there and make sure that it looks good. I can go home to G28, and then I can do an M30 from there to reset my program. And from there, I go ahead and put my percent sign back in. Having my percent sign is really important, so when my program loads, it knows when to stop loading in there. So I want to start and end it with the percent sign. So to make this part, it's pretty straightforward. I'm not going to include the parting in there because, like I said before, normally I would not probably part off a 5-inch diameter part. I have parted off 5-inch parts, but I would not probably make my standard for doing that. Okay, so now I will save this part. So I'm just going to do a quick file, and I'm going to save as 00004, and this is actually, I'm going to just put that in as A, and then save it there. And so I'm going to go ahead and shrink some of these guys down. I'm going to pull up Immersive. If you have a different back plotter, that is totally fine. Whether it's, I don't know. I've used a couple of different ones. This one works real well, but you do have to have this system. You can go to the CNC plotter lathe. We'll go ahead and just open that up first, run it through real quick. Starts up on the Haas control, looks very similar to what our machine looks like. We can go into our desktop. And we'll go, I did not save that as an NC program, so I can go in and either one of those, there's the same program. Put that in there, and here is my part, and I can reset, and cycle start. Plots my part through, does my finish pass, and it looks like it does 2 finish passes, but what you're seeing is the roughing, then you're seeing the pre-finish pass that takes out some of these steps. Then you're seeing the G70 taking care of the final part of this thing. So if I don't do that, I could go over to the TL1. I noticed something wrong with the TL1 earlier, and I'll try to, if I can remember, give them a call, contact them about that. Okay, so same thing, I turn the machine on, receive from the 232, and I go back to my desktop and find my program, all programs. 4 is my program. I've got my machine sitting here, just the TL1. Now, if I go to 4-inch long, 5-inch diameter stock, which is what it should be, and then I go ahead and run my part, we will have a problem. If you notice, it's actually starting in front of it. It starts behind the part, so it makes all the cuts. It does all the actions, but it doesn't come out quite right because it's not the right size. So what I did before is I just stopped it. I'm going to go ahead and go back into single block. I want to get that out of the way. I'm going to change material down to 4 inches, reset, and then I'm going to go back out of single block. I'm going to run my part through. First couple passes won't work or won't be doing anything. So I can graphically check that still by looking at where I'm at in my position. So I'm down here at position. I got my work offset. I'm at 4.13. I'm cutting down those steps, even though I haven't cut anything off my stock. I'm doing that. So now I'm starting to take some cuts, and the front of my part starts to look pretty good from here. So I'm down to 3.51. See, it's leaving the 10,000 stock on there. 200 thousandths per pass. So we're getting our material knocked off there pretty decent. So now I'll start stepping my angle. Go down to 2 inches 20 thousandths. There's my pre-finish pass, knocking out some of those steps. Cut my radius. Ran into the headstock because of my material. Here's my finish pass, taking it to 3 inches in diameter. I just turned the corner. You can see moving X and Z. Now you can see moving X and Z again for the chamfer. Go back to 4 inches. Out of the way. Okay, so that's how you can pretty easily create a program with some chamfers and some angles. You need to be able to do the math on these things. You know, it's really important to be able to do those things. So work on that. If you've got some type of simulation, then you want to run it through there. If you use immersive, then just kind of follow exactly what I did, and you'll be in great shape. Okay, have a wonderful day.